Hello students, a very warm welcome to this lecture number 14 of Electrostatics, and today of course we are going to deal with the second session of electric potential. If you haven't completed the earlier session yet, please do complete it. Anyway, we are going to get started with altogether a different concept in electric potential today. But at the same time, make sure you're making notes and yes, you're sharing this video and you're liking this video. But guys, let me tell you, today what we are going to do, we are going to do some of the questions, like some of the concepts, not really the question, but some of the concepts that was asked in your JEE Mains and JEE Advanced. We'll be also dealing with those kind of questions in the upcoming sessions. But typically we'll be taking up these kind of concepts and questions that was asked previously in JEE Mains and JEE Advanced. Good evening, Saloni. Good evening. Good evening. Good evening. Yeah, this can be a sort of revision for you. Yeah, of course. And yes, let me tell you guys, this is going to be a very easy lecture. So make sure you're noting down everything that we are discussing. Especially, it's just about practice. So practice it. Yes, Saloni, you need to practice. Be it revision. Electrostatics, the key is practice. Electrostatics, mechanics, or electricity, magnetism, all of it. It's mostly practice. So do practice. And that being said, students who don't know me, I'm Murlidharan Gopalakrishnan. I completed my MS in electrical engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I have filed 25 patent applications in India and abroad. No, Saloni, this is not board. No, this is not board, guys. This is JEE. So make sure this is not your board revision, but the concepts can be the same in your board. For some of the good questions, should the board student be attending, like IIT JEE lectures? Yes, why not? Because the concepts are same. Until unless we don't proceed to problems, and if we have decided not to proceed with IIT JEE preparation, like problems, what do I mean? Like JEE PYQs, JEE kind of problems. Like very like there isn't much difference. It's basically the approach and the way of understanding things. That's the difference between your IIT JEE preparation and board preparation. Your board preparation can be a little bit simpler. You can just move like concept by concept, and that should be good enough for your exam. At the end of the day, it's going to be derivation. We'll be, of course, be discussing derivations that would be required for your board, but maybe we'll be also discussing methods that are easier. And of course you can do them in your board as well, and that are different from your board kind of expectations. But when it comes to your board expectations, it's going to be subjective questions, but we'll be dealing with objective questions typically in the sessions, and it will be mostly around the kind of concepts that you need to understand to solve problems. So in a way, they mingle up board and IIT JEE. You can take it up as a revision session for IIT JEE, but I will be discussing some approaches as well in the session, right? So from the options, how do you come to infer what should be the solution? For example, there is a JEE Advanced or JEE Mains problem in this session. I'll tell you how to get started around your JEE Advanced problem. Given in 2 minutes, how do you do it? These are some of the things. And even if you're a board student and if you've decided not at all to do IIT JEE Mains or IIT JEE Advanced, let me tell you guys, the difference is the way you understand the concepts and the way you solve the problems. There isn't a lot of difference when it comes to at least your JEE Mains. JEE Advanced, it's about a little bit of practice and a little bit of advanced understanding of concepts. Other than that, I don't think there is much difference. But yes, you need to put in the efforts. You need to really understand the concepts. You can't memorize things, and that is my utmost efforts in getting you to this entire session. Trying to make sure you are not memorizing things, you're understanding every single bit and pieces of concepts. So yes, you need to make sure you're understanding concepts in this session. You can take it as a board revision, but I wouldn't typically say this would be a board revision. You can just learn it, and don't be afraid of JEE Mains. It's an easy task given that you understand how to do things. Alright guys, and that being said, on this 8th of November, we are going to have the most competitive gamified IIT JEE battle ever. It's going to be Unacademy Combat. So enroll soon. If you're planning to do it, do it. If you are even not planning to do it, do attempt it. There is no harm in attempting any of your this kind of competitions, especially if you're a JEE aspirant. Even if not, try attempting it, guys. It's worth it. Enroll today with Murli Live code. So do it, compete, win rewards. And what do we have for you? We have amazing prizes for top 100 winners in every session. So this is going to happen, every week, but we are going to have amazing prizes. You can win Apple products, guys. So do enroll to it and try to download Unacademy learning app. If you don't have one, download it and start running it. It's going to be the most competitive one, guys. Many rewards and prizes for you and for you only. So do attempt it. And that being said, students, if you are not yet on our Telegram channel, do quickly get onto our Telegram channel. First of all, you need to download Telegram app from your Google Play Store and App Store. And once you download it, you just need to click onto this link, which is available in the description box of YouTube, or else just type in JEE_English. You'll be able to find it. And what is the benefit of getting onto Telegram channel? You will be able to get live, instant, and as well as before time updates on every session that is happening on JEE English. Not just me, but whatever session or whatever lectures are being conducted by JEE English lecturers on Unacademy learning app as well. So it's both YouTube and Unacademy learning app. You will get update in one place, that too before time. That is going to be this Telegram channel of JEE English. So do click onto this link available in the description box below. Do download this Telegram app if you don't have one from Google Play Store and App Store. And that being said, coming Sunday, we will have the fourth part of A to Z of capacitors, which is going to happen from 11 a.m. to 2 p.m. We'll possibly shift it to Saturday, Sunday, and 2 sessions on Sunday. So far the plan is just one session, but we'll make it 3 sessions for your capacitors, so that you have hand in hand going on capacitors along with electrostatics. Typically you can expect questions in both electrostatics and capacitors in your JEE Mains and JEE Advanced exam. And guys, it's a free of cost special class, so stay tuned. Follow me on Unacademy learning app to get updates, to get live updates. If you're already on Unacademy learning app, do follow me and you'll get live updates on every special class happening. And typically do get onto the Telegram channel, you'll get updates before time. And that being said, if you haven't yet covered A to Z of units, dimensions and measurements, so if you have noticed, I typically take up A to Z sessions on capacitors. We have completed one on conductor electricity, and this is going to be on capacitors, of course, this week. But this one was on units, dimensions and measurements. This was A to Z of units, dimensions and measurements. And how many sessions? Just in 4 to 5 sessions. So think about it. You just attend 4 to 5 classes and you are able to do 1 to 2 questions or 2 to 3 questions in your JEE Mains and JEE Advanced. So that is the beauty of this topic. It's the easiest one, the less time taking one, and not only that, you'll definitely get a question in your JEE Mains and JEE Advanced. And typically everything that you need for your JEE Mains and JEE Advanced preparation has been discussed, guys. If you attend these sessions, you will be able to solve your JEE Mains and JEE Advanced problems. So do check it out, do complete it over Diwali or over the weekend, don't miss it out. So this is going to be the easiest, most scoring, topic in your JEE Mains and JEE Advanced, typically the easiest one. And these sessions were also free of cost. And to attend these sessions live and to get live notifications to attend these sessions, you need to download Unacademy learning app. All you need to type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app. Just click onto this link once you type in Unacademy on your Google Play Store and App Store, and then do not hesitate to click on the install button. Just click on that install button, guys, and post that. You know what, you will have an awesome learning app, the most downloaded educational app across India. And that being said, not only that, we also give you access to the best in class features, free special classes, and also to live quizzes that is happening every now and then. Especially we have on Tuesdays this live quizzes going on. So if you have this Unacademy learning app, you can start attending the live quizzes, and these quizzes have, this is also again a free of cost feature, and these quizzes have model problems like what you can expect in your JEE Mains and JEE Advanced, and also many PYQs. So there is no reason not to download Unacademy learning app. So download it today and install it and keep it on your mobile phones handy. And also to attend this, the India's most competitive IIT JEE battle, you need to download Unacademy learning app, guys. If you don't have one, do download it. Hi Divya, good evening, guys. And that being said, if you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, a complete package, it's going to be Unacademy subscription. Yes, guys, I'm talking about Unacademy subscription, the best thing that you can have for your JEE Mains and JEE Advanced preparation. So what do you get on Unacademy subscription? Best educators across the nation. You get to learn from the best educator across the nation. Not only that, you get to attend daily live interactive classes with the best educators across the nation. You'll undergo a structured, intensive and extensive program. So what do I mean by structured, intensive and extensive program? You will be attending sessions where you'll be taken from the basics until advanced. You'll be briefed and you'll be explained. You'll be taken through every concept in a very structured manner. So we will take you step by step through the entire journey. It would not be it would be a hassle-free journey for you. It would be the easiest thing that you could do, but at the same time it's going to be an extensive and intensive program in a very structured manner. And not only that, you will get access to timely doubt clearing session. Every week we would have a doubt clearing session and you can come and ask your doubts, and that to dedicated doubt clearing session for each topic. So think about it. If you haven't understood even a single concept, you can get it cleared from the best educators across the nation, guys. So that is the beauty of Unacademy learning app. And not only that, Unacademy subscription, and not only that, guys, we also keep conducting national level test series, and in the structured program also you undergo many quizzes. So this way you are becoming a champion. You're becoming like a champion, and you're become a champion. So that is the awesomeness of an Unacademy subscription. Just these many things, the best educators across the nation, the best technology that you can have for your JEE Mains and JEE Advanced preparation, and the best kind of structured learning programs that you can have for your JEE Mains and JEE Advanced preparation. So to get this, all you need to do is click on the left hand top corner extension bar and choose plus, and then choose IIT JEE as your goal, and then click on the get subscription button. And guys, it's one subscription, unlimited access. So that's the beauty of Unacademy subscription, guys. So you can enroll to as many programs as you want, and this all comes at a reasonable price of only 2,100 only. That means less than 70 rupees a day. Less than 70 rupees a day is what you have to pay for the best, complete package and a champion's tool for your JEE Mains and JEE Advanced preparation. And it's going to be all online. You can attend the classes from anywhere. And guys, how do you get to this price point? You need to apply Murlidharan coupon to get to this price point. And typically 24-month subscription is meant for 2022 aspirants, students in 9th, 10th or 11th class. So this is typically going to be for you. And students, if you are looking for convenient payment options, we as well have that as our in-house option. So we as Unacademy have pay in parts option, which you can make use of to split your payment into multiple parts. And not only that, guys, we also have no cost EMI. So this is one of the options where you don't have to pay any interest on your subscription purchase. And using these two options, you can split your payments into multiple parts, and you need not take the burden of paying all the fee at once. This is the awesomeness of Unacademy subscription. So you may want to try it out. And guys, we also have traditional payment methods like debit card, credit card, UPI. You can also check them out, whichever you're convenient with. And if you're a long-term and dropout, this is going to be the most suitable program for you. So typically meant for like 12th class students, long-term droppers, etc. And this is going to only cost you less than 2,900, 2,888 only. Yes, guys, it's less than 2,900, and we have 6,000 and 7,000 plus materials for your JEE preparation. And right now there are like 1,000 plus live programs just going on for JEE Mains and JEE Advanced preparation, and this all comes at the cost of less than 2,900. After you apply Murlidharan coupon, you will get the best discount and you will get to this price point. So do not forget to apply Murlidharan coupon and do not miss out any discount on your subscription purchase, guys. So yes, this is the best thing that you are going to have for your JEE Mains and JEE Advanced preparation. We have dedicated programs for you. Do not hesitate to give the test series. Do not, if you are already on an Unacademy subscription, do not hesitate to give the test series, and do not forget to enroll to Optics Basics to Advanced. So you're planning to purchase subscription, this is the right time, guys. Enroll soon and start attending Optics Basics to Advanced coursework. Even if you're on an Unacademy subscription and if you're thinking about it, this is the program that you want to enroll to. The reason it is, we have just completed, a major part of optics, which you can cover, through recorded classes. But we are going to get started with a very interesting topic around this optics. You may want to get started. It's still independent of rest of the topics that have been taught until now. But still, you want to make sure you're maintaining completeness by attending the recorded classes as well. Enroll soon if you're already. So it has just been launched. Only a minor part of it has been covered, which has a good amount of weightage. You may want to attend that as well. But start attending the classes, guys. Enroll to this program and come to these classes. It's going to be awesome. And this happens every day at 6 p.m. Okay. and this is going to be from Tuesday to Friday. So yes, Tuesday to Friday, and some days extra classes, etc. You can get all the notifications once you start following me on Unacademy Learning App. And that being said, guys, our team, JEE English team, and we have the best team, guys. We have IITians and IITians, head of institutions, and we have started courses for 2021 and 2022 aspirants. For 2021, we have courses on electromagnetism, differential calculus, chemical kinematics, and optics basic to advanced. So what about optics basic to advanced? It's a complete coursework. It's going to be a comprehensive coursework for your optics. It's going to cover both, your JEE Mains and JEE Advanced syllabus. Everything will be from basics. And not only that, guys, we have also launched courses for 2022 aspirants. We have launched a course on mechanics. We have launched a course on redox, on equivalent reactions, graphs, sets, and relations. And do remember, practice, practice, and practice makes human perfect. Do not forget to share this video. Do not forget to like this video. And guys, let me tell you, of course, in electrostatics, it's all about practice. So if you're attending this session right now, get your pen and paper, share this video with your friends, and ask them to come on board. But at the same time, start taking down the notes, practice it along with me. Every single thing that we are going to deal in this session is going to be a mix of concepts and problems. So you may not want to just attend the session like just as if you're watching the video. You may want to practice along with the rest of them. It's fine. Many times it's going to be super conceptual concepts, etc. But you need to understand something. Practice is very important over here, and also you need to take down the notes. So yes, guys, if you remember, we told something, if I have to take from, if I have to move an object, in this case a charge, from a zero potential point that is like V is equal to 0 up until some, just this later is just an analogy, and to some point where the potential is delta V. Okay, so you would do a work of Q naught into delta V to make this happen. So this is going to be the work done, right? So let me ask you a question. So I think, many times when you do derivation, you will come across something very different, like not what you expected. Sometimes you get a negative sign. Why is that happening? Let's understand it. Okay, let me just take a blank sheet, and that would be more better for the understanding of this concept. So yes, guys, a very important concept. You need to understand this thing. So let me quickly grab a blank sheet. All right. Notice things very carefully. I'll also show you what we derived yesterday. It's not a problem if you haven't attended the earlier class. So let's say there is a charge plus Q. Okay. And let's say there are like 2 points in the space, etc. One, it's at infinity. You don't know, it's at infinity away. And other is at some point near it. Okay, it's radial distance r from it. Okay, in this case, it just looks like it's x-axis distance r from it, but for now, just assume it's radial distance. And the other point, as you can see, is at an infinity point, right? So we are not discussing about that. I'm not writing down that infinity. So now the thing is, let me ask you a question. So what should be the work done to move it from infinity? Let's say there's a test charge, to move it from infinity up until r. Okay, is it a positive work or a negative work? It's going to be a positive. A very important concept. I know you guys might know this, but still everything is dependent upon understanding these concepts. Sometimes you can quickly come up with solution based on this concept. So you need to do some positive work. The field is not working for you. If you are noticing the field, it is repelling. If let's say this is a positive test charge, in that case, what it is doing? It is repelling this charge. So the field is like this from this plus Q charge. Okay. So but yesterday, if you remember, like we were deriving the equation, we said it's f dot dr, and we derived, initially for the work done, etc. So now let me ask you a question. What kind of work you're doing? Positive work. We got like 1 by 4 pi epsilon naught, etc. 4 pi epsilon naught. We said it would be like q into q naught divided by r square, and you're going to integrate this entire thing up until how much for each dr you're calculating it from infinity to your r, right? So what did we get? So this is k. Just going to change this as k. We got something like work done is how much? K q naught divided by we'll come across something very interesting. Okay, this has been changed to k. Has been changed to k. So we got something like, if you integrate 1 by r square, it's going to be minus 1 by r. Okay, let me just change the color of this thing. Let me just choose q naught. Going to be just changing the color a bit so that we understand this best. This is going to be minus 1 by r. Of course, minus 1 by r, just differentiate it. So this is going to vary from r to infinity. So finally we got work done as something like minus k q naught by r. Is this what we got? Hi Krina. Hi Krina, hi. So yes, so this is what we got as our answer, and you are wondering, okay, the work done, is it negative or is it positive? I didn't move in the direction of field, but this is the work that you have done against the system. This creates a sort of confusion. This is the work that you have done, but this is the work that you have done against the system. Right? This is not negative work done. This is, if this was a positive charge, not a negative work done. Work external would be negative of this W, and this would be like K Q naught by R. Okay, typically you're integrating this, you're noticing, all right, I'm getting it as minus 1 by R, minus of minus 1 by infinity. In this case, showing you this what has been done in the bracket. This would look like minus 1 by r minus of minus infinity, since you have moved it from infinity to r, right? This would be like 1 by infinity, so this is 0, and this would be just minus 1 by r at a distance. Mathematically it looks as if you have done negative work, but you haven't done negative work, but you have done a positive work. This is the work that you have done against the system, and so you would make it as minus of minus q. But okay, now let me ask you a question. Let's erase this part. So this is the work that has been done. Okay, and this you would typically see would be written as something like, we understood this was q naught. Generally, how you're moving a test charge, it's going to be v final minus v initial, right? V delta v, it's nothing but v final minus v initial. In this case, this is Vr minus V infinity. We know V infinity is nothing but 0. We take it as 0. Still, you are getting as if you are just going by the regular method, you're getting as if, by mathematically you're getting as if there is a negative work being done. Right? Hi Suraj. Yes, minus sign indicates a good question. I'll come to your question. I'll again start explaining that point. What is negative work? We discussed it. I'll just do quick. So negative work, what is negative work, guys? Negative work, let's say, is like, I'll explain it separately, okay? You'll get a good clarity about the negative work. Negative work is where, the work is automatically being done by the system. You are not doing any work. Positive work is where you are doing the work. So as per integration, you are getting, like negative. So VR appears to be minus k q naught. Okay, now like a question might arise in your mind, is this negative potential or positive potential? Okay, this is the work that you have done to move this charge from infinite to a point r in the space. Mathematically it looks like negative, but you know what, it cannot be negative. We know the force is increasing as you're moving towards it. Okay, force is increasing as you're moving towards the charge. Now the thing is, let me ask you a question. If I'm going to say it's VR minus V infinite and you have found everything. Now the thing is, do you think the potential here would be negative, or if I move it a little bit of distance, what does this potential indicate? So this potential indicates as if if you take if you move it a little bit, you would see that you increased the distance and you reduced the force. The potential at this point was higher than this point. You have 2 points in space from charge Q. This is from charge Q. One point is this, nearer to charge Q, okay, and another point is little farther from charge Q. Now let me ask you a question. You have to move from P1 to P2. Do you have to do the work, or system will do the work? System will do the work. Then if I'm going to say, okay, forget all of this derivation part, guys. Okay, let's come finally to the thing that we had to discuss. Forget the mathematical part of it. And hi Samyak, hi. And I'll get to your question quickly, Suraj. I'll give you a good analogy of what is negative work and positive work, and that would be very interesting. But before that, let's just do a thing. So what I'm saying is, you're moving from point P1, a test charge from point P1 to P2. Okay, and field is in this direction. Charge Q naught, you moved it in this direction. This is, there is like okay, let's just think about it in terms of field is like this. Okay, it's a non-uniform field, but just like field is like this. Now what I'm asking is, if I'm going to ask you what work you have done to move it from point P2 to P1, what would you say? Work done by me, or work done by you, or external work done. It's nothing but some Q naught into dP2 minus Vp1, which is going to be negative, right? Because you're moving from that point where the force was higher. Typically, if you're thinking about having a charge plus Q over here, the force was higher. Okay, this field is due to charge plus Q. The force was higher over here. The repulsive force was more at this point than this point. So hence you did not do any work. It is as if the system has done the work. So Vp2 minus Vp1 should be negative. Substitute this thing in this equation, and you'll understand that potential at point R cannot be negative, given that it's a one small correction. Take you back. So this would be rather be positive. You'll find it out as KQ. Right? Assume this point to be infinite. Negative work has to be done. So this will be negative. Just put it out. You'll find out in this equation, just VR equation, just put it out. Minus KQR minus 0 is like 0 in this case. Okay. So that way you'll understand your potential is actually positive. So that is mathematical derivation. But let's come to the question. Okay, I hope you understood this point. This is just a concept anyways, KQ by R. Let's come to the concept what Suraj has asked. Really interesting one. I think I can make use of this as well. But anyway, let's do a thing. Let's take a blank sheet and understand this. What is negative work? A very interesting question, guys. Many times you don't understand this. I'll give you the best analogy for you to understand it better. Let's say, just a moment. What is a negative work and what is a positive work? Let's understand. Okay, very important, because in this chapter we are going to do that. And anyway, in some places you can solve your previous year problems using this concept. whether it was a negative work. Throughout this chapter, in this session, you'll definitely understand. So you have a ladder like this. So this is the ground level. Okay. Now you have one person standing over here. Okay. So now think about it. So this guy, this is not the exact way to understand it, but a part way of understanding. Okay. Now there are two ways of thinking about. The funny way would be, like there is another guy over here, and what this guy is doing is this guy is trying to push him down. Okay, if forget that initial movement, etc. When you had to push him down, what you had to do, you had to just slip him off this ladder. You just slipped him off the ladder. Don't try it at home. What would happen? This guy would fall automatically due to gravity. Now what has been done? This guy really did not do any work. He might have done only a little bit of, like the impulse that he has given, etc. to make it happen. Okay, so this guy automatically came down. He pushed him a little bit. Let's say this guy is like a Superman, this guy in the red. So he came down, just like this, right. So no efforts. So he is saying, wow, I've done the work, but you know what? I did not put in any efforts. I saying no efforts. And he gives the credit goes to gravity. Now this is an example of negative work. All right. No, guys, this is not a tough concept. This is a very easy concept. Don't worry. If you're not understanding it, do let me know. I can take it up, a couple of seconds in Hindi. If you guys want it, we can do it for, moment in Hindi. But this channel is supposed to be like a JEE English channel where we are supposed to deliver lectures so everyone understands it. They don't understand English. If you want it in Hindi, yeah, we can do it. Just this concept, huh? So he says, the credit goes to, this was an effortless thing. The credit goes to gravity. So really the work was done by the system. So if you take it as a closed system and this guy is the external person. So this is the external person. So this guy would say, I am the external person doing the external work, but I haven't done any work really. I've just given that initial whatever push is needed, and this guy automatically went and stood on the ground due to gravity, which is negative work, which was done by earth or gravity, any mass. Now let's take an example of positive work. Guys, if you are not understanding this concept, you can let me know. We can quickly take up this concept in Hindi as well. That should not be a problem. Alright, now let's come to the other part of it. Now, let's say now this guy is not over here. Now he is rather given some other task. The effortless thing is gone. This external person sees that, okay, this was no more an effortless person. I'm not going to give credit to gravity because the process is different. Now what is happening is, there is again this red guy who does not work. He is going to be a part of the system. And now this blue guy comes in. He says, you know what? I am the external person. Now this guy has to make sure this guy in red reaches on the top. On the top. Okay, forget this part. So now if I have to make sure this guy reaches the top of this cliff, etc., this staircase, and need to lift him. Think about yourself. You need to lift him. This guy is saying now, God, this is not an easy process. I have to do the work. And he says that all credit goes to me, but I would, blame the gravity. Because this gravity is the reason I have to do the work. If gravity did not exist at all, this gravity guy did not exist at all, I'm not supposed to do any work. The gravity existed, so I have to do the work. I have to do the work. It's no more an effortless job. It's a little bit, not a little bit, maybe depending on the weight of the other person. So it is something where this guy had to do a lot of work. Okay, this guy had to do some real work. The work was not done by the system, but the work was done against the system. Think about this red person, this gravity, and the staircase as one system. Okay, so now he realized that, now this guy in the blue said that, I did the work. I did the work. This is like a situation where, work external is positive. Because a work was really done by this guy. So this is a perfect example of positive work done. And the work was done against whom? Work was done against gravity. Yes. He says that if at all the gravity did not exist, I did not have to do any work. I had done the work against the system, against the gravity. It's against the system. Earlier, it was in the direction of the system. That the system was taking care of the work. This guy felt as if he has done the work, but he hasn't done any work. The work was done by the system. This, I believe, gives you a perfect understanding of, negative work, positive work. For an example, in this case, if at all, this is just a later analogy, guys. This is literally not true. But let's say the charge was at a higher potential. Okay. Plus Q charge, and you brought it down. But if at all this was a negative charge, entire thing would be different. Think about it carefully. Okay. This anyway, while you are substituting sign, it would be minus Q naught or minus some, 10 nanocoulombs, etc. to automatically become a negative. If you have to bring it from higher potential to lower potential, you need not do any work. System will do the work. Right? But you would feel as if you have done the work. So that is the negative work done. Alright. So yes, we derived this equation, which should be correct. VR is equal to KQ by R. Right? Alright, we just derived this as well. So yes, if you remember, potential, what it is, scalar or vector? It's a scalar quantity, and at any point if I'm asking you to find out the potential, you add up the potential due to each and every charge. This is V1, this is V2, and this is V3. It's going to be KQ by R1, etc. You add it up. Scalar quantity, and scalar quantities can be negative. Potential, electric potential is an example. Potential for electric potential, for negative charge is going to be negative. Think about it. We explained this point yesterday, right? You can later on watch the video as well. Going to be again a whiteboard explanation of how you find out there's a negative work, or negative potential or a positive potential. What does it mean? If I had to bring a charge from infinite to vicinity of negative charge, you don't have to do the work. Or a positive test charge. Whereas in the case of positive charge, you need to do the work to bring the positive test charge because it's rippling. Alright. So that being said, let's say there is some work that you do. Let's say delta V or delta W work that you do. And in this case, this is the delta W external work that you do. And what would that be? You would state it typically, from all your mechanics, etc. F dot dr. Okay, some dr distance you have moved. Let's say you have moved this charge by a dr distance. So what is the work? Work is going to be F dot dr. Okay, we'll come to the point of what you are thinking about. Don't worry about it. Okay, but what kind of work have you done? You have done a negative work. So if I move dr distance this way, it's a negative work. Right? Moving a positive test charge in the direction of the field is the most effortless thing that you can do. So you're doing the work along the system, or maybe you're not doing the work, the system is doing the work. Hence, this is negative work. Right? So I would write it as, F as, not exactly F as, but external work that you have done as minus F dot dr. In this case, just it's as if you're substituting the magnitude, guys. Okay, it's as if you're substituting the equation, you're substituting the magnitude. It's not like just magically this minus appeared. This minus appeared because I've substituted the magnitude. Okay, if it was negative charge, Q0 was negative, then you're probably doing positive work. If this is a positive charge, generally we take positive charge as the test charge. We say this is a negative work done. A negative work done, we write it as minus Q0 into dr. Okay, this is nothing but F. Alright, from this we know what is the work done. Work done is nothing but whatever movement you have made against a potential delta V. From there we got this. I just cancelled out. Let me do it over here. So if I am going to state this is nothing but Q0, you have moved it in the delta dr direction, I mean like dr distance, and you have moved it such that its potential has changed by delta V. Delta V potential change. What has happened? Q0 into delta V. So from here you will get delta V or dV is equal to minus E dot dr. Q0 gets cancelled out, and you will see nothing but, I'm going not writing down the dw point. Okay, going to be E minus E dot dr. Alright guys, with this we'll get into a very interesting question based on the same concept. Think about it carefully. And what is E dot dr? E dot dr is a cross product of electric field and position vector. What? Position vector. And what is position vector? R final minus R initial. Right? Simple. That's it. Start working on this. The point charge positive Q0 is moved from. So what is being said in the question? I'll brief you out very quickly. So okay, anyway, let's start reading the question. Now you need to think about it and you will come up with the answer and verify if you're getting the correct answer. Don't worry if it's a basic thing and if you got it wrong, but you can still walk around it. A positive charge plus Q0 is moved from one vertex to the diagonally opposite vertex of a square of side 1 meter in an uniform electric field of 1 Newton per Coulomb. Right? Now what is being asked? The change in the potential of the charge during this work done is, the charge is moved diagonally. The charge is not moved like this, but it is rather moved diagonally. Okay. Hi Ashwin, hi. So now get started on it, but anyway in the options I've given you all negative answers. So notice it says the work done by the system, or no, it's not the work done against the system in the direction of the, where you have to give only that initial effortless process. But anyway, get started on it and come up with the answer. So this you'll understand a very important concept. An electric field as shown over here or in this direction, guys. Okay, if you take this to be x and y, there is no component, more aptly said. Explain this. This is x, this is y. Okay, this is x, this is y. The electric field is along x. No component along. Alright, now think about it carefully, come up with the answer, guys. Take your time, take your time. It's a very easy question. It's an easy question, students. It's an easy question. Take your time, think a little bit, try answering it, start commenting it, start typing out in the chat box. And if you're watching it late, start commenting it. Alright, get started on this question. First of all, when you are moving in this direction, if this is a square of 1 meter, 1 meter, this electric field was given how much? 1 Newton per Coulomb, something like 1 unit, I guess. Two ways of thinking about it. Let me come to a very important concept, but before that, let me come to a very easier way of doing this. What did I say? Potential is nothing but minus of E dot dr. So we discussed this. Alright, and trust me guys, it's a very easy chapter, but your focus is very much right, because many concepts are involved in this. Now in this case I can just call it as, E dot r. What is r? R is nothing but r final minus r initial. Okay, that is all fine. So there should be some, if I'm going to take this as a dot product, there should be, let's say I'm just strictly talking in terms of magnitude, er cos theta, right? What is r? This 1 meter, this 1 meter. If I'm moving along the diagonal, r is √2 meters, a diagonal length, right? And what is the direction? So r final is in this direction. Then it this way. Be the best. Oh, let's do it. Anyone coming up with the answer? We'll understand few things around this. So this is your direction of, right? This looks like this, but yeah. All right. The direction of r is something like this, right? That means your field is something like this, your r is something like this. What is this angle? This angle is 45 degrees, isn't it? It's 45 degrees. This entire thing is 90 degrees. This is just, like an angle bisector. So this theta is 45. Substitute it. We know a few things. R √2, electric field 1, and magnitude of electric field 1. And what about your cos theta? That is cos 60 is equal to cos theta, sorry, cos 45. Sorry guys. This cos theta is equal to cos 45, which is how much? 1 by √2. Just substitute all of this value. Minus, since you are doing work in the direction of the system. √2, no 1, I'm sorry. It's same thing, but I wrote down E first. Let's write it down in the order. 1 into √2 into 1 by √2. What is this? Minus 1. That is it, isn't it? It's just minus 1, guys. So your work done was, so it was all in SI units. So work done was minus, so this is potential. Okay, this minus 1 volts. Okay. Okay, anyway, test charge is not, value is not given to us, but work done is negative. Right, you understood this point. Right, simple. Do you have any issues around this? No? Have you moved it from a higher potential to low potential, or a low potential to higher potential? You have moved it from, if I'm going to say this, you have moved it from, its work done is negative. If work done is negative, what have you done? You have moved from higher to lower or lower to higher? Higher to lower. Higher to lower potential. This was like delta V should be negative in this case. Now I'll come to a very important part of the concept. You understood this point, okay? Delta V negative, you moved from higher to lower potential. It's like pushing from the top. Work done is negative, you moved in the direction of the field. Alright, answer should be in this case minus 1 volt. Delta V we found out is minus 1. Just now we found out delta V, right? Delta V was nothing but minus E dot R, came out to be minus 1 SI units, minus 1. Okay. Now let me come to a very something that I haven't told you before, but something that we can understand today. Alright, I'm going to erase this part. Later on, you note it down. You watch it. There's nothing, just to be values and substitute them. Now, the thing is, can we do something like this? Or to move the charge rather than moving diagonally, I would say these both are same. Is it? So instead of, let's call this as path 1, I've taken path 2. Just like, you know, from one vertex to another vertex, adjacent vertex, then this adjacent vertex to the diagonally opposite or the adjacent vertex. Okay. Instead of going from, let's say this is like vertex V1, this vertex V2 to vertex V3. One way is directly move from V1 to V3. Other way is to move from V1 to V2, then to V3. They are the same thing, guys. Why? Any guesses? Conservative. Right. So if at all, I say work done. Okay, we are starting from work done. Anyway, we'll eventually arrive to the solution as well. That delta V13, or this point is 1, this is 2, this is 3, same as adding up potential difference between V2 and V1, and then V3 and V2. Okay, so what I'm saying is, if at all I'm doing a work, we will calculate it and see that. Okay, don't worry about it, we'll calculate and see that thing. What I'm saying is, work done through path 1 is equal to work done through path 2. Work done from 1 to 2 to 3 is same as work done directly. Okay, this is P1, entire thing. The work done from 1 through 3 same as work done from 1 to 2 to 3. Alright, what does this mean? In this case, do we have an inference? Yes, of course. What is the inference? Delta V path 1, or I'm going to say this as 3, 1. Between 3 and 1. Between 3 and 1. Of course, final potential minus initial potential. The same as delta V 2, 1 plus of or minus of plus of delta V 3, 2. Down and see whether this works. Yes, I guess so. This works, doesn't it? V2 minus V1 plus of. I'm elaborating or I'm expanding this term. Plus of V3 minus V. V2 gets cancelled out. Finally, you got it as V3 minus V1. And what would be delta V3 1? Nothing but V3 minus V1. Hence you understood this point. Now let's understand it through the numerator. I'm just erasing out this point. No, maybe we will take it up on the next page. I'm saying if you moved it this way or this way, you moved it from year to year, 1, 2 and 3. Okay, then you move from 1 to 3, same as you're moving from 1 to 2 to 3. We already saw delta V3 1 was something like 1 volt. We derived this, right? Like we calculated this in the earlier thing, like using E dot dr minus E dot dr. Okay, so this was like minus 1 volt. Alright, now the thing is, let's do it for the next set, just to see what we have said is correct. So 2 works I have to add. Okay, why are we discussing this? I'll come to that point, don't worry. In your exams this can be asked. So 1 work I had to do was to move it from 2 to 1. Okay, now this is a second scenario. We are just analyzing the scenario. Maybe this can be wrong as well, but we know this is correct, but still let's calculate and see whether this is correct or wrong. I'm saying work net in this case when I am moving from, let's call this as path 2. This is the path 2. This is the path 1. We're not concerned about path 1. We already got the answer for path 1. We are now concerned about path 2. And this would be, now we are talking about path 2, guys. Right? Path 2 work. This has 2 work that you have done. One is from 1 to 2, and the other one is from 2 to 3. Right? Let's calculate it. What is happening? From 1 to 2, it was nothing very complicated. It's basically E dot dr minus E dot dr. Let's keep 2 to 3 as it is, minus E dot dr. Okay, in this case, like I'm just going to write it. Minus E dot r. And in the next case, it's like, just let's keep it as work 2 to 3, and maybe we'll just deal with it separately. And what is the electric field direction? Along x. What is the direction that you have moved? Along x. How much distance you have moved? 1. What is the angle between both? 90 degrees. 1 into 1 into cos of, 0 degrees. I'm really sorry, theta is 0 degrees. Cos of theta 1. That is going to be how much? Minus 1 into cos of theta 1. How much is it? Cos of 0. Right? That is minus 1 plus something. This something turns out to be, like a value, positive, negative value, or entire assumption also. But Let's see what happens and we'll understand something very. I'm just keeping this -1 and just taking out a new kind of equation. This is minus of E dot R2. This was just R. So this is R2. Okay. What is the direction between R2 and E? This 90 degrees. Hence, this -1 plus of something. Okay. Into cos 90. Okay. E is in this direction. And you moved in this direction. Right? Hence, this is 0. This was how much? This is 90 degrees. You got -1. A little, there should be a Q naught. Got the Q naught part of it worked on this. Missing out something, that would be Q naught. It's nothing, it's just Q naught should be present over here. Should be another Q naught over here. Okay, hope you understood the point. There should be Q naught, 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 and there should be another. Look like Q naught. But anyway, what would be the potential change? Delta V, just Q naught, just into Q naught. Okay, hence delta V would be just -1 volts. This is what? This is work done. Right? -1 volt into Q naught. Hence, we would finally get your delta V in this case as how much? -1 volts. This is going to be like what? Q naught into delta V. So, something very interesting. This was for part 2. For part 2 as well, we found out, okay, just writing it down as part 2, -1 volts. Right? Really simple. Here also there. Alright, that is it you have to understand. And let's say you are given a question, not like this. Let's say you have a question. This question, what is happening is there is a charge Q. It's moving this entire thing, to this diagram. You have some charge Q, and what I'm saying is you'll understand the importance of this concept as we get into this. Don't worry about it. What I'm saying is you have moved it all around, like this, in a uniform field. Something like this. There is an uniform field. Back to this thing. So this kind of questions you can expect, you may not expect a direct one, but you can expect some questions. The space has entirely uniform electric field, some E, which is going to be some E naught into X cap, etc., or I cap. What I'm saying is, you decided to move this charge, but you didn't like moving it straight away. What it was, you moved it some this, like this, like this is the path you chose. Now, finally your Q naught is somewhere over here. Let's give it a little bit of different color. That was past, this is present, now Q is over here. So the thing is, isn't it same as moving this guy directly? Let me. Isn't it same as if you moved this guy from here to here? Yes. Okay. I call this to be work 2, and the shift in potential as delta V2. So this is how your question will come up, right? Like not maybe directly what you expected like earlier. Work 1 and potential changes delta V1. You can typically say that even if you're moved all around the space in a not uniform electric field, delta V1 is equal to delta. This is what you would expect. Not like maybe even like earlier. Okay, simple. Something to note down. Definitely. Two different paths. This was path 2, whatever path 1, and this was right. Note it down, guys. All right. With this, let's get into the next. A very interesting thing. It's a very easy one. Don't worry. Typically, when you see rings, spheres, electrostatics, don't worry about it. Especially when it comes to electric potential, don't at all worry about what is being asked. Just jump into the question and start solving it. Take a couple of minutes, try to have a look at the question, and then get started. What does the question say? A circular ring with radius r having a uniform charge distribution of q on its perimeter. Okay. Then find the electric potential at a point x on its axis. This axis of the ring. A very simple question. Think about it carefully. It's a very easy one. Take your time. And let me tell you, the question is easier than what you would expect. You can take it as a point charge. Of course, you cannot take it as a. Typically, two kinds of questions will be asked around this. I'll come to that. One would be like, they will have like, multiple rings. They will ask you potential, and the other would be like a graphing based question using this multiple rings or a single ring. A change in potential, etc. Write out. So first of all, we need to derive the potential. So yes, thing is very simple, guys. It's a very simple problem. But let me ask you a question before we get started with the problem. What do you think will be the potential at the center? Will it be 0? Electric field was 0. What do you think the potential would be? Could the potential over here be 0? Not equal to 0. Okay. Scalar quantity, not 0. Okay. No field effects cancelling. I'm not saying scalar quantity cannot be 0, but in this case, fields are not cancelling it out. Because it's not field, it's not a vector quantity, it's a scalar quantity. You're not worried about how the force is applied. What is the potential at that point? We brought it from infinity. Alright. First of all, let's do one thing. That is like, as usual, what we do. That is, it's a uniformly distributed ring. So we will define something known as linear charge distribution, which is going to be q by the perimeter of this ring. It's all distributed on the perimeter. It's of radius r. It's going to be 2 pi r. Okay, let's define this thing first. Separately. Everywhere it has charge lambda. So of course you would have to take elemental area. So linear charge density q divided by 2 pi r, just like how we did in our electric field case. It's going to be the same thing. It's very easy. Don't worry, guys. Easier than electric field. Even if you haven't done electric field, you can understand it from here. So if I'm going to take some point on this ring, some elemental point on this ring. So this, I've told you, the charge distribution is lambda. It's uniformly charge distributed, right? Very q by 2 pi r. But take an elemental area like dr in this case. What is the charge on it? Charge on it would be dq, okay, which is nothing but lambda into, that's it, right? So you got another thing. For an elemental area, dq going to be lambda into dr. Now, first of all, let's dive into something very important. Okay, what is that important thing? Important thing is nothing but we know something known as VR, potential at some point. VR due to some, in this case, let's keep it as dVR due to this elemental, not area but elemental, length. It's dV, and what this should be? This should be like a dq by some distance from this point. We are assessing at this point, from distance from this point, which is going to be some, like, let's keep it as like small r. Keep it as small r. dq by small r. Now, thing is, what is this value of r, guys? And now I'm not interested in this elemental area. Do a thing. Let's take up an elemental area over here. If I'm going to take an elemental area over here, is this going to be r? So no vector is associated. Do remember, this is just a scalar quantity, right? What about this r? This r and this r is same. How much is the value of r, guys? Is it constant? Yes, it is constant. This is also r, this is also r, and what is the value of r? R is going to be just as simple as, try to understand this point. This is a right angle triangle. Imagine in 3D, it's a right angle triangle, and even in the earlier case, okay, this is r, radius r, from this center of the ring to here, it's going to be r, to the perimeter it's going to be r, and this distance, as you know, is x given to you, right? How about in this case? In this case, this is this is r, capital R. Let me just correct it quickly. Let's of maybe like red color just for one of these lines. Have a good understanding. So this is r, and this is how much? This is x. So for both these points, if you have noticed, what is r? R is same. This is again a right angle. Think about it in 3 dimensions. It's going to be like, all right angles, right angles, right angles, right angles, right angles, r and x distance. Like, one side is r, one side is x, capital R and x. And everywhere it's only distance r. Like every single element on this ring is at a distance r from this point x. From this point. Right? Simple. So we need to find out another thing that is going to be r. Okay, let me just quickly erase everything and do a thing. Write down lambda. Lambda was how much? Q by 2 pi r. You understood this point. And this ring, add lambda charge, linear charge distribution on it. Not charge distribution, but rather linear charge. Uniform linear charge distribution. It can be a varying thing. You need to take decisions accordingly, and you need to work accordingly. And guys, What about at this point? It was r. R, as you know, this x. We know r's value is how much? Under root of, we already saw it's going to be uniform. R square plus x square is like a constant, guys. So you don't even have to worry about it. This is, we are just deriving it for the sake of deriving it. We are writing it down for the sake of writing it down. Even for graphing based questions, only one thing you need to note, tell you what it is. What about at the center of the ring? Then you'll notice something amazing. Okay. So one more thing we needed was dq to complete our calculation. That dq we derived and we calculated to be lambda into dr if this element is dr. So this was like lambda into dr, this element length. Let's just keep it as lambda into dr. Because lambda is anyway constant, so we can derive. And we finally add the equation for dv, which was k dq divided by r, where r is constant. We'll finally substitute it. Now to find out the total potential of the ring, we need to integrate this, right? V net is equal to integration of dv, just like what we used to do before. There's nothing in this. This could be the simplest thing. We have the k, yeah. K, I'm taking it out. R, I'm taking it out since this is constant. Only dq is what you have to integrate. Directly you can say dq integrated as q. It's basically k cube. That's it. Right? There's nothing more in it. Or you do lambda dr, typically do the entire integration. So when you do it, you will still get it. Don't worry about it. Alright guys. Okay. Alright. So this being done, let's come to a very important conclusion. First of all, write down the entire thing, and that is going to be what is the net potential at some point x in space at a distance x from its center. It's going to be k into q, capital Q, total charge distribution, divided by r square plus of x square. That is it. Right? Now, next question arises in our mind. What if x is equal to 0? X is equal to 0. This is center. Right? This is where x is equal to 0, right? What is the potential at that point? At x is equal to 0, V net x is equal to 0 is how much? K q divided by under root r square plus of 0 square. Yes. In a symmetrical, we understood that point yesterday itself when we were dealing with triangular charge distribution, etc. Understood that point. So this is nothing but under root of r square plus x square, r square plus 0, maximum. Even though you understood that point, this is the maximum. It's not 0, it's maximum. Whereas in the case of your ring, you remember, electric field was 0. So this is the max. Right? Isn't it? This is the max. Right? At r is equal to 0, at x is equal to 0, you got the max potential. Now let's move on to the graphing concept. That's very important for understanding. You understood these basic points around it. Now let's say you have axis like this, another axis this. Okay, we don't we need the entire axis, right? Let's draw a longer axis. So you have Just a moment, guys. Okay. This is y-axis on which I'm going to plot potential. Okay, maybe, yeah. And on x-axis it's just distance x. How does this look like? That's the question. Take a nice color. Maximum, how much over here? K Q by R. Of course, minimum is at infinity. How would the graph look like? To the right, that is in this direction, potential would keep decreasing as move. Because what is the equation, guys? Equation is something like this. This is positive, negative. You would have inverted. Do remember, this is positive Q. This is the way it would look like. Negative Q, you would have to invert it. I'll do a thing. I'll also draw it for negative. It as negative. But before that, let me quickly do a thing. Okay, fine. Let me write down the value. Okay, this is how much? KQ by R, and V potential at any point x, it's going to be KQ divided by R square plus x square. Right, that's it. All right, this is right. All right, guys, just give me one time. Just access very blunt. Okay, anyway, you understood this point. That's it. This is the point. Vmax. This is also known as Vmax, sometimes denoted as V naught, etc., depending upon the graphing system. Now this would look something like keep reducing, and ultimately which. And what about the negative side? What about the negative side? Remember, during our electric field discussion, we had something different. But now, let me tell you, it's going to be just a mirror image, guy. Why would anything change? It's positive Q, right? It's positive Q, scalar quantity, direction does not matter. Let it be negative. How does it matter? Right? If this is origin, this is the negative direction. How does this matter? Does not matter, right? To appear as if going to also appear like the same one. Okay, we approaching near infinity, to be approaching just like what you saw in the earlier graph. This is only true if your ring is positive. Positive charge distribution. What about negative charge distribution? Time negative, you would have minimum at the center. If this Q was negative, you would have minimum at the center. How much is that going to be? Minus KQ by R. It could be just Q could be negative and it could appear the same way. These kind of things are used. Somewhere you need to be cautious about. And as you approach infinity, you will see max potential. Right? Similarly, it's just going to be a mirror image. It's still going to be negative. For a negative charge, the potential is going to be negative. Right? Potential is going to be negative. Right? That is it. This happened again. But So do remember, depending upon the kind of charge distribution, potential graph also varied, and this would be for negative charge distribution. Negative charge distribution. Simple as that. Right? Inverted. Take a mirror image on this side of x-axis, but don't do that. Try to understand the concept first of all. And what was this point? V minimum. Simple. The entire ring concept is simple, guys. That is it. Okay. So yes, you would see some graphs like this, and in some of the questions, this would be defined as a V naught, and this would be defined as like x, etc. This is distance from axis. You understood this is distance from axis. I'm just defining it over here. Distance on axis. Right. Let's do a thing. Let's take up rest of the problems in the upcoming session. But I hope this session was super conceptual and super intensive for you. Start graphing your electric potentials and electric fields. You would see something very interesting around them. We'll take up more and more interesting problems like change in potential, like what you could expect in your JEE Mains and JEE Advanced, and also something around the disk. You think disk problem is challenging? No, trust me, disk problem is not challenging. It's going to literally take you, like 4 to 5 lines. If you understood the concept, it's going to take you 4 to 5 lines to solve. You have to find a potential at a point in disk, and if you're asked to derive it, or if you're asked to, suddenly, come up with an answer, I'll tell you like, small tricks as well as to solve it from the options in tomorrow's session, but as well as to solve it, mathematically. But that's not a big deal. Don't worry. It's totally a very easy concept. All you need to do is stay tuned and keep taking notes. Do not forget to practice. Do not forget to imbibe the concepts right away. Electrostatics can be done very quickly and very easily during a revision or during any of your preparation, given that you take down the notes. Alright guys, and that being said, we'll take up more problems, we'll come up with more interesting graphs, but do not forget to enroll to Unacademy Combat. Unacademy Combat is going to be the most competitive gamified IIT JEE battle ever, and you can win prizes like Apple products, etc., and anywhere around 100 plus and odd winners will win the prizes. Do not forget to enroll it with Murlidharan coupon. It's going to be super intensive. It's going to be super awesome. You'll get to learn a lot, and do not forget to attend this battle. It's going to be the biggest battle ever, and you'll win lots and lots of rewards and prizes. So do attend it. And students, if you're already on an Academy subscription, or if you're planning to purchase an Academy subscription, enroll to Optics Basics to Advanced coursework. And guys, let me tell you, this is an amazing coursework. This is going to be a full-fledged comprehensive coursework for your JEE Mains and your JEE Advanced learning, and this includes both wave optics and ray optics. Of course, we are right now on the ray optics part, so it has just been launched, so enroll soon. We are going to get started with new concepts from tomorrow, so do not forget to attend this session. If you're already on Plus, this is the time to enroll, because many of the questions are asked from the concepts, but also try to complete the past lectures. Anyway, we're going to jump into new concept, and if you are on Plus, this is the course, guys. This is the course to get started. So do get started, and do get started. Don't wait for anything. Enroll soon. And that being said, this Sunday we will have a special class from 11 a.m. to 2 p.m. on A to Z capacitor series. We may probably even shift some classes or have many classes on Saturday and Sunday. Back-to-back sessions. But yes guys, stay tuned and start attending these special classes. They are meant for you. They are quite easy. And students, do not forget to like this video. Do not forget to share this video. Do not forget to keep smiling. Acquire knowledge, but also share it and grow your knowledge. Keep sharing, and keep sharing, and keep liking the videos. And students, do not forget to share it. And students, let me tell you something interesting. Ignore gossips. Work hard and smart to achieve your success. And that being said, If you're not yet having a Telegram app, just download it from the Google Play Store and App Store. That's all you need to do. Just download it from Google Play Store and App Store and click on to this link, which is available in the description box below. And once you click onto this link, you will get onto our awesome Telegram channel, JEE English Telegram channel, where you will get live before time updates on every class happening on JEE English channel or any lectures that our team, JEE English team, conducts on Unacademy Learning app as well. Just click on to this link. It's available in the description box below. If you're downloaded already the Telegram app, and if you're on the Telegram app, just type in JEE_English, till you'll be able to find it. And guys, that being said, if you haven't yet started with units, dimensions and measurements, get started today, because you have got free special classes on Unacademy Learning app, and this was all covered on back-to-back session, just 4 to 5 sessions. This is all the kind of time that you require to complete units, dimensions, measurements, experimental methods. It's all, guys, free of cost special classes. And let me tell you something interesting. These special classes covered like PYQs, different kind of model problems, etc. And students, easiest topic could be something like units, dimensions and measurements, like what you can expect in your JEE Mains and JEE Advanced. Typically expect at least one question, and this all comes at just 4 sessions. That's quite interesting. You may want to attend it, and it's also less time taking, not just in terms of doing it now, but also in your exam. So yes, definitely something that you want to attend. Do get onto Unacademy Learning app and do follow me to get more updates on such special sessions. And if you don't have an Unacademy Learning app yet, just download it from Google Play Store and App Store. All you need to do is type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy Learning app, the most downloaded education app. And guys, once you get onto this link, click on this install button. That's all you need to do. Once you do that, guys, you will have an amazing education app on your phone, which impacts near about 7 million lives a day. And this is the kind of impact that we are creating today. And students, not only that, once you download this app, you can attend the special classes from anywhere. And as you know, it's free of cost special classes. We also have many free of cost features like quizzes. We have quizzes, and you can attend these quizzes from anywhere as well. But you know what? These quizzes are coming up with a national level competency with PYQs and model problems, like what you can expect in your JEE Mains and JEE Advanced. There is no reason to download Unacademy. There is no reason to not to download Unacademy Learning app. So do download it today. Click on that install button. Do not at all hesitate to click on this install button. And that being said, students, if you are looking for a complete package, a champions tool for your JEE Advanced and JEE Mains preparation, it's going to be Unacademy subscription. Why? We have the best educators across the nation all on one platform. So if you're looking for even topic experts, we have them on our Unacademy subscription platform. And not only that, guys, you get to learn from this, best educators across the nation on a daily interactive classes. This is the awesome thing. And not only that, you'll also get to get your doubts cleared from them on timely basis, and you'll undergo an extensive and an intensive structured program. Yes, you will be attending classes followed by the doubt clearing session, that dedicated doubt clearing session, where you can get your doubts cleared from the best educators across the nation. Yes, this is what Unacademy provides you on subscription platform. And more importantly, you also get to attend national level test series. You get to understand your standings from the leaderboards and dashboards. Yes, guys, this is an amazing platform and the best thing that you could have for your JEE Mains and JEE Advanced preparation. And if you can afford it, and if you're willing to afford it, this is the best thing for your JEE Mains and JEE Advanced preparation. And all you need to do to get this awesome Unacademy subscription is click on the left hand top corner extension bar and choose plus, choose IIT JEE as a goal. With this, you will get ready for both JEE Mains and JEE Advanced. A race to become a champion in JEE Mains and JEE Advanced. And then click on the get subscription button. And one subscription, unlimited number of programs is what you will get. And guys, you know what, this all subscription comes at an affordable cost of 2,100 only. So it's going to cost you only 2,100 per month, or less than 70 rupees a day. Not even 70 rupees a day, less than 70 rupees a day. And guys, how do you get to this price point? You need to apply Murli Live coupon to get the best discount, and to get the best discount on your Unacademy subscription purchase, but also to get the best discount. Also to get to this price point. Yes. And that being said, do not hesitate to purchase an Academy subscription today, because we have convenient payment options for you. You can split your fee into multiple parts using our paying parts, in-house feature and Academy feature, or you can also make use of no cost EMI. So you can use both of these options to split your payments into multiple parts, and this is our in-house feature, and with no cost EMI you would not pay any interest on your EMI as well. So this is the awesome thing. So these two payment options will take away the burden of paying all the fee at once. You can split your payments into multiple parts using Unacademy subscription, guys. Sorry, Unacademy payment options. And we also have other attractive payment options like debit card, credit card, etc. You may want to check them out as well. And that being said, guys, if you are in like 12th class, or if you're a long term, or if you're a dropper, so yes, if you're a dropper, if you're in long term, if you are like in 12th class and just looking to prepare for 1 year, this is going to be the ideal one for you. You may want to opt for 12-month subscription, and again this is quite economical. It comes at a cost of 2,888 only, less than 2,900 is what you need to pay for this awesome platform with 6,000 plus materials and 1,000 plus live programs right now going on. And how do you get to this price point? You need to apply Murlidharan coupon and avail the best discount. Do not miss out a discount on your subscription purchase. So avail you the best discount today by applying Murlidharan coupon and get started today. If you are planning to start it, it's the right time, because this is the time where most of the educators are hosting classes dedicated for your revision, droppers bash, 2022 target, etc. So the best time would be now. And guys, if you're already on an Academy subscription, do not hesitate to give the test series. Do not forget to attend Optics B2A Basics to Advanced coursework. See you in the next class. Take care, stay safe, bye bye. We'll have more interesting lectures. Let me tell you, deriving the potential at a point on the axis of the disk is as easy as deriving the potential at a point on the axis of a ring. So stay tuned, share this video, do not forget